Good morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so today, we're going to actually wrap up this chapter. We're going to take a look at section 8.5, and then after the break, section 8.9. Your assignment will be 8.5, 8.9 in the chapter review. Tomorrow, I'll be back at 10 o'clock for an office hour, and then class at 11, from 11 to 12:30, where we'll have a review. And then tomorrow, you'll take your chapter 8 test to be finished by tomorrow night at 11:59 p.m. Before we go on and take a look at section 8.5, do any of you have any questions concerning the assignment over the weekend? If so, now is the time to speak. All righty, well then we'll go ahead and get started. So here we have section 8.5. This has to do with solving absolute value equations. So first of all, let's review the idea of absolute value and how it works. Let's say we have a number line, and we have the number 7, the number -7. The absolute value of a number is the distance from that number to 0 on the number line. So for instance, let me back up a little bit. When you're asking for the absolute value of a number, you put the number in between two vertical bars. So the absolute value, that's how we would label it, of 7 equals the distance from 7 to 0 on the number line. Well, the distance would be 7 units. So the absolute value of 7 is 7. But what about the absolute value of -7? What is the distance from -7 to 0 on the number line? That's also 7 units, because distance is not measured in negative units. It's either measured in positive units, or in the case of how far is it from 0 to 0, 0. So the absolute value of a number is either positive or 0. This being the unique case of 0, every other possibility and absolute value would be a positive result. Okay, so the distance from -7 to 0 is the same as the distance from 7 to 0. Any questions about that before we continue? All right, let's say we had the following equation. The absolute value of x equals 7. Well, what number or numbers could x be where the absolute value would be 7? Well, if x is 7, the absolute value of 7 is 7. Or if x is -7, the absolute value of -7 is 7. So this absolute value equation produces these two situations. What's inside has to either equal what's outside, or if it equals the opposite of what's outside, its absolute value would still be the number outside when that number is positive. Okay, so again, the absolute value of x equals 7 leads to x equals 7, or x equals -7. What if we had the following situation? The absolute value of x plus 3 equals 7. Well, then we have the same scenario. What's inside would have to equal 7, because the absolute value of 7 is 7. Or what's inside would have to equal the opposite of 7, or -7, because again, the absolute value of -7 would be 7. So again, we get these two scenarios, these two equations. But now solving each of these two equations, x plus 3 equals 7, subtract 3 from both sides, we get x equals 4. X plus 3 equals -7, subtract 3 from both sides, we get x equals -10. So I'm claiming there are two solutions to this equation. Let's check our work. Let's see. If we take the equation x plus 3, absolute value that is equals 7. If x is 4, we get the absolute value of 4 plus 3, which is 7. The absolute value of 7 is 7. If we use this situation and plug it in here, we get the absolute value of negative 10 plus 3 equals 7, which is the absolute value of negative 7, which also equals 7. So we have two solutions. Any questions about that? All right, let's take a look at some more examples here. Let's say we have the absolute value of x equals 90. So then this would say that x has to equal 90, or x could be the opposite of 90, or negative 90. Because if x is 90, the absolute value of 90 is 90. If x is negative 90, the absolute value of negative 90 is 90. So these two solutions check. Let's see here. The absolute value of x minus 7 equals 4. So that means x minus 7 has to equal 4, or x minus 7 has to equal the opposite of 4, or negative 4. If x minus 7 equals 4, adding 7 to both sides, we get x equals 11. If x minus 7 equals negative 4, adding 7 to both sides, we get x equals 3. Let's check our work. If x is 11, we get the absolute value of 11 minus 7 equals 4. The absolute value of 4 equals 4. 4 equals 4. It checks. If x is 3, we get the absolute value of 3 minus 7 equals 4. 3 minus 7 is negative 4. The absolute value of negative 4 is 4. 4 equals 4. The answer checks. Again, any questions about this process? Okay, let's see. How about this example? The absolute value of 5x minus 3 equals 22. So that means what's inside the absolute value bars has to either equal 22, or it has to equal the opposite of, or negative 22. Solving 5x minus 3 equals 22. We'll add 3 to both sides, and we get 5x equals 25. Divide both sides by 5, and we get x equals 5. Solving the second equation, we'll add 3 to both sides, and we get 5x equals, what would that be? Negative 19, is that right? Then dividing both sides by 5, we get x equals negative 19 fifths. Let's check our work. If x is 5, we get the absolute value of 5 times 5 minus 3 equals 22. But 5 times 5 is 25. 25 minus 3 is 22. The absolute value of 22 is 22, so 22 equals 22. X equals 5, checks. If x is negative 19 fifths, the absolute, can't talk, the absolute value of 5 times negative 19 fifths minus 3, the 5s would reduce. Negative 19 minus 3 is negative 22. The absolute value of negative 22 is 22. 22 equals 22. And again, the solution checks. All right. Let's see here. What about this situation? We've got, where did it go? Here. 2x plus 18, the absolute value equals 0. All right, so that means either 2x plus 18 equals 0, or 2x plus 18 equals the opposite of 0. What is the opposite of 0? It's still 0. So in fact, these are duplicate equations. So if we have an absolute value equal to 0, that's only going to produce one unique equation. So now, solving this equation, subtract 18 from both sides. 2x equals negative 18. Divide by 2, x equals negative 9. Let's check our work. The absolute value of 2 times negative 9 plus 18 equals 0. The absolute value of negative 18 plus 18 equals 0. Negative 18 plus 18 is 0. The absolute value of 0 equals 0. 0 equals 0, and it checks. We get negative 9, one solution. So if an absolute value is equal to a positive number, it produces two solution possibilities, two equations. If an absolute value is equal to 0, there's only one unique equation to be solved. All right, let's take a look at another example. Let's say we've got, how about this one? The absolute value of 3x plus 6 equals negative 9. Okay, so now we've got 3x plus 6 equals negative 9, or 3x plus 6 equals the opposite of negative 9, which would just be what? Positive 9, right? Okay, well, solving the first equation, 3x plus 6 equals negative 9. We'd subtract 6 from both sides. 3x equals negative 15. Divide by 3, x equals negative 5. On the right side of the equation, we have what? 3x plus 6 equals 9. Subtract 6 from both sides. 3x equals 3. Divide by 3, x equals 1. Okay. Well, let's check our work. Tell you what, let's go to the next. Well, I think I can fit it in there. Let's try. Okay, if x is negative 5, I get the absolute value of 3 times negative 5 plus 6 equals negative 9. 3 times negative 5 is negative 15. Negative 15 plus 6 would be what? Negative 9. Absolute value of negative 9 equals negative 9. But what does the absolute value of negative 9 equal? It actually equals 9. So we get 9 equals negative 9. That's not true. How about x equals 1? We get the absolute value of 3 times 1 plus 6 equals negative 9. This is 3 plus 6, which is 9. The absolute value of 9 equals negative 9. But what is the absolute value of 9? It's 9. Does 9 equal negative 9? No, it doesn't. False, 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 false. No solution. Well, let's go back to the very beginning of this problem. Remember, I said an absolute value could be equal to a positive number or 0. So an absolute value can't be equal to a negative number anyway. So no wonder there was no solution. Okay. So I guess those would be those extraneous solutions they've talked about that just don't work. So if you've got an absolute value equal to a positive number, you've got two possible equations. If it's equal to 0, you've got one possible equation. If it's equal to negative 9, you could produce two possible equations, but when you solve them and get answers, if you check those answers, they're not going to work. Okay, now, all this is fine and dandy if we've got just an absolute value set equal to a number. But what if we've got some other things involved? For instance, the absolute value of 6x minus 3 plus 7 equals 28. What we need to do, first of all, is take a drink of water, and then we need to isolate the absolute value term before we decide how to split it up into possible equations. So the first move here is going to be to subtract 7 from both sides of the equation. So now I have that. So I have an absolute value all by itself equal to a positive number. So that should produce two possible equations. 6x minus 3 equals 21, or 6x minus 3 equals the opposite of, or negative 21. But again, I isolated the absolute value term before I did anything else. So now 6x minus 3 equals 21. We'll add 3 to both sides of the equation. 6x equals 24. Divide both sides by 6. X equals 4. That's supposed to be an equal sign. Okay. Second equation. 6x minus 3 equals negative 21. Add 3 to both sides. 6x equals negative 18. Divide by 6. X equals negative 3. So let's check our work and see if they are correct. Let's take x equals 4. So that would be the absolute value of 6 times 4 minus 3, oops, plus 7 equals 28. 6 times 4 is 24. 24 minus 3 is 21. So we have the absolute value of 21 plus 7 equals 28. The absolute value of 21 is 21. 21 plus 7 equals 28. 28 equals 28. It checks. Let's take this one. The absolute value of 6 times negative 3 minus 3 plus 7 equals 28. 6 times negative 3 is negative 18. Negative 18 minus 3 is negative 21. So we've got that situation, but the absolute value of negative 21 is 21. 21 plus 7 is 28. 28 equals 28, and it checks. But again, the first thing we did was to isolate the absolute value term. Okay, and let's see here. How about this one? The absolute value of 8 minus 5x plus 6 equals 2. Okay. So the first thing I need to do is isolate the absolute value. I'm going to do that by subtracting 6 from both sides of the equation. But now I have an absolute value equal to a negative number. So there's going to be no solution. Now, I can still come up with possible solutions, and sometimes WebAssign asks you to do that. So you'll just have to look and see what the directions are. If it asks you to find what they call extraneous solutions, we'll jump ahead here and ignore the fact that we already know there's no solution. And this would give us these two possibilities. 8 minus 5x equals negative 4, or 8 minus 5x equals the opposite of negative 4, which would just be 4. So solving the first equation, I'll subtract 8 from both sides, and I get negative 5x equals negative 12. Divide by negative 5, x equals 12/5. Solving the second equation, I've got 8 minus 5x equals 4. Subtracting 8, we get negative 5x equals negative 4. Divide by negative 5, we get, slow down here, we get x equals 4/5. So let's see about checking our work on those two problems. I think what I'm going to do is I'm going to recopy the equation and the potential solutions on the next page so I have more room to work. So 8 minus 5x, come on, oops. The absolute value of 8 minus 5x plus 6 equals 2. And then we had 12/5 and 4/5. X equals 12/5, x equals 4/5. So let's try each of those solutions. 12/5, we would have this. The absolute value of 8 minus 5 times 12/5 plus 6 equals 2. Well, inside the 5s would reduce down. 8 minus 12 is negative 4. the absolute value of negative 4 is 4. So I get 4 plus 6 equals 2, 10 equals 2, so that doesn't work. Let's try the 4/5. The absolute value of 8 minus 5 times 4/5 plus 6 equals 2. The 5's reduce out. 8 minus 4 is 4. The absolute value of 4 is 4. 4 plus 6, 10 equals 2. That doesn't work either. No surprise there. So again, there's no solution. But if they ask you to find the extraneous solutions, those would be the ones, but those are not correct. They don't work. Okay? All right, how about this situation? We've got negative 10 times the absolute value of 16x plus 4 minus 3 equals negative 3. Now, you might look at this equation and say, aha, it's equal to a negative number, so there's no solution. But wait, you can't draw any conclusions until you've isolated the absolute value term completely. So the first thing we're going to do is add 3 to both sides. Now we have negative 10 times the absolute value of 16x plus 4 equals 0. Oh, then we'll divide both sides by negative 10. So we get the absolute value of 16x plus 4 equals 0 divided by negative 10 is 0. So after we get it all ready to go, isolating the absolute value, it's set equal to 0, which means there's one equation, 16x plus 4 equals 0. Solving this equation, we'll subtract 4 from both sides. 16x equals negative 4. Divide by 16. X equals negative 1/4. Let's plug that into the original equation and see what happens. Negative 10 times the absolute value of 16 times negative 1/4 plus 4 minus 3 equals negative 3. Okay. 16 times negative 1/4, the 16 and the 4 would reduce to 4 over 1. 4 times negative 1 is negative 4. Inside negative 4 plus 4 is 0. The absolute value of 0 is 0. So I've got negative 10 times 0 minus 3 equals negative 3. Well, negative 10 times 0 is 0. 0 minus 3 is negative 3. Negative 3 equals negative 3. So it is correct. But again, don't draw conclusions until you've isolated the absolute value term. No extra terms, no coefficients outside. Okay? All right. Another possibility is where you have an equation that contains only 2 terms, and each one of them is an absolute value term. Okay? If we just have one absolute value term in an equation, you want to isolate it from everything else. If you have 2 absolute value terms, you want them separate, one on each side of the equation. Well, let's look at the possibilities here. We could say that what's inside of this first one equals what's inside of the second one. We could say what's inside of the first one equals the opposite of what's inside of the second one. We could say that the opposite of the first one is equal to what's inside the second one, or the opposite of the first one is equal to the opposite of the second one. So we've actually got, looks like 4 possibilities there. But upon further inspection, notice if I take this first equation and I multiply both sides by negative 1, don't I get this bottom equation? So these 2 equations are, shall we say, redundant. So I'm just going to get rid of this one. I don't need it because they're the same equation. They just don't look the same initially. Likewise, take these 2 equations. If I take this equation and multiply both sides by negative 1, I get this equation, which means this one isn't necessary either. So what it does is it leads us back to, again, just two possible equations. One of them is we'll take what's inside of the first one, set equal to what's inside of the second one. The other one will take what's inside of the first one equal to the opposite of what's inside the second one. So again, we get two different equations which produce a potential of two different solutions. All right. So let's solve that top equation. We're going to subtract 3x from both sides. We're going to get x minus 7 equals negative 21. Add 7 to both sides, x equals negative 14. So that's a possible solution. We're going to get, let's see, the second equation becomes 4x minus 7 equals negative 3x plus 21, distributing that negative sign. Okay, so then we will add 3x to both sides, and we get 7x minus 7 equals 21. Add 7 to both sides, 7x equals 28. Divide both sides by 7, x equals 4. So we've got this, and this is our possible solutions. I'm going to rewrite this on the next page. Let's see, the absolute value of 4x minus 7 equals the absolute value of 3x minus 21. And our possible solutions are negative 14 and 4. Okay, if x is negative 14, we get the absolute value of 4 times negative 14 minus 7 equals the absolute value of 3 times negative 14 minus 21. 4 times negative 14 is negative 56. Negative 56 minus 7 would be negative 63. The absolute value of negative 63 is 63. 3 times 14 is negative 42. Negative 42 minus 21 is negative 63. The absolute value of negative 63 is 63. So that solution checks. Let's take the x equals 4 and try it. The absolute value of 4 times 4 minus 7 equals the absolute value of 3 times 4 minus 21. 4 times 4 is 16. 16 minus 7 is 9. Absolute value of 9 is 9. 3 times 4 is 12. 12 minus 21 is negative, negative 9. The absolute value of negative 9 is 9. It checks. It checks. Okay, so let's review. If you have an absolute value equation, the first thing you want to do is isolate the absolute value if there's just one of them. At that point, if the absolute value equals if that's set equal to a positive number, that produces two equations. What's inside equals the positive number. What's inside equals the opposite of the positive number. If after isolating an absolute value it's set equal to 0, you just get one equation. What's inside set equal to 0, and then solve it. If you get an absolute value equation that once you isolate the absolute value it's set equal to a negative number, there's going to be no solution. But if you're asked to find the possible solutions, you would still go through the process with the two equations. If you have two absolute values, you want them separated and then deal with it as we did this last situation. Okay, so do you have any questions before we wrap up this first part, which is 8.5? All right, then I will stop the recording.